Hello everyone, this is Jiang Li. I'm a student of IBM Advanced Data Science Professional Certification Program on Coursera. As a requirement, I'm making this video to present my final project. My project is about building a loan payment prediction model. Why I'm doing this model? The use case is getting a well-performed prediction machine learning model for banks that can minimize the risk while maximize the loan interests. If the lender criteria is too strict, fewer loans get approved, which means there will be less interest to collect. But if the lender criteria is too lax, many loans may default. This would be a huge risk and cost for banks. So machine learning can help to solve this problem. The dataset I'm using is a dataset contain 400 historical loan records. Mm, Before moving forward, let's take a quick look at my IBM Watson Studio notebook. Next, we will take a look the PowerPoint I made for this presentation. Um, the dataset has 10 columns, two dummy columns that I already deleted, 8 columns left. The target column, the target value we want to predict is loan status, whether a loan will be paid off in time or not. The 7 input variables we are using for predictions are principal, terms, effective date, loan due date, age, the age of applicant, education, the education level of our applicant, the gender of our applicant. For data exploration, let's take a look about our date shape. Then let's have a look about our data distribution characteristics in terms of its tendency and standard deviation. Then we check the correlations between different columns. From this, we are using Pearson method to check the correlation between different columns. From this table, we can see there are no strong correlation among different columns. This is a good sign. That means we don't have worry about the overfitting problems caused about the correlations between different columns. Further, for data exploration. Next, we will check our data quality. We will use a data frame is now method to check whether our dataset has some missing values. From this table, we can see our dataset is cleaned. It's well prepared for our data consumption. Next, we will have some data visualization to examine the relationships between the input variables and our target values. For example, the relationship between principal and payment status, the age and the low payment status, the day of a week and low payment status. Next, we will do two feature engineering about our data in order to get better data performance. The first is one-hot encoding because our dataset contains some categorical data such as terms, age, gender, and education. Transform this categorical data into numeric data can heavily improve our data performance. Other than one-hot encoding, we also transformed our data and normalized our data using standard scalar method to ensure our data followed a normal distribution so that our model can have a better performance. For algorithms, we are using k nearest neighbors, decision trees, support vector machine, and logistic regressions. These four algorithms are very popular and powerful algorithms for classification problems. Our loan payment performance is a classical classification use cases. So we are choosing these four algorithms and will choose the best one as the final model. For model performance evaluation indicators, we are choosing accuracy, Checker similarity score, F1 score, recall, and entropy to evaluate our models. For model evaluation, I choose two different approaches. The first approach is for single model. I compare the model accuracy between the model performance on training set and on test set. For second approach, I also compared different models performance among these four different models. Among these four models, our KN model has the highest Checker similarity score and the best F1 score. So I choose KN model as the final prediction model. Um, One interesting finding is these four models are all tend to have a lower testing accuracy compared with training accuracy. It may result from overfitting or result from the small data set. So for future development, it's better to train our model and test our model on a large data set. Also, our model are built on the four traditional algorithms. Maybe some more advanced algorithms such as CNN and STMs can be helpful to improve our model performance. Mm, Another idea for future model production is maybe to build a real-time production model at a large scale will be more desired in real industrial use world. That's it. Thanks.